Okay, let's begin the understanding of single field analysis, printout analysis, and the summary of single field printout analysis, and especially summary in case where stat pack is used. Okay, fine. So there is a definite we know that almost 10 zones, but yes, we'll talk about first zone, that's patient data and test data. So in which age of the patient is must be entered accurately. That's crucial because whenever we compare the sensitive point of each point raw data to the stat packs data, then age of the patient is most sensitive. Okay, the sensitivity of the patients will be compared with the normative data of the same age group. That's why age entering date of birth is most crucial. You have to understand. Second zone, that is the reliability zone, and reliability index is foveal threshold. Just understand this concept. The acceptable range of reliable indices depend upon the clinical situation. For example, in case of suspected glaucoma, C index is nearly 100% perfect. It's very important. In case if you suspect glaucoma, if it is advanced glaucoma, then that's difficult. Suppose you are trying to do visual field in patient with whatever macular problem, whatever problem that is. In that case, foveal threshold definitely goes down, isn't it? But if you do not do refractive correction well, then foveal threshold definitely goes down. So in that particular case, in case of suspect of glaucoma case, that particular case you have to be so cautious about reliability indices. Okay, even 1% of the reliability indices will have impact on the diagnosis. That's very important. Okay, in established and advanced cases of glaucoma, up to 20% is acceptable. So, in case of established and advanced, where visual acuity always already goes down, visual field is narrower. At that particular case, yes, we can understand that a little bit fluctuation can be acceptable. If the error crosses 33%, this is not considered reliable in any case, and there will be something XX in the monitor. Zone 3, raw data. It is exact sensitivity of the patient. So the only way tell whether the scotoma is absolute or relative is seen by raw data. If you can, the only way that you can say that sensitive is a sensitivity absolute scotoma or there is relative scotoma, you can see raw data. Okay, a 0 decibel in the raw data indicates the absolute scotoma, and that's always there in case of 30 dash to 25 dash. So what's there? It's basically blind spot, isn't it? In case of blind spot, it is always 0 decibel, which is approximately 15-degree temporal and slightly lower, isn't it? Okay, so the interpretation of the printout is never complete without seeing the raw data. It's very important. You have to see raw data because from raw data we compare. Now onwards, from raw data onwards, we use stat pack, isn't it? Yes, definitely not in gray zone, but gray scale. But then after we use stat pack, isn't it? Gray zone, till now there is no use of step back, there is no use of normative data, isn't it? So remember, the depth of field defect is better appreciated in gray scale than the probability plot. It's very important but it's quite fascinating. The depth of field is even appreciated in grayscale, but never ever use grayscale for the diagnosis. Okay, it's very very bad. From the grayscale, one can have rough idea regarding depth and the pattern of the field effect. So it's rough idea and very useful for explaining patient. And I have already explained what are the uh, faults of grayscale definitely. So analysis data bring the following analytical data. So raw data is analyzed. Okay. First raw data is compared with the normative data. Then we got what? Total deviation, probability plot, and total deviation numeric plot. Then establishing pattern from total deviation numeric plot. If we eliminate seventh position, then we will get pattern deviation numeric plot, isn't it? And the definite probability is pattern deviation probability plot. Then establishing global indices is always the case of total deviation numeric plot, isn't it? Just don't confuse with it. Okay. Glaucoma hemifield test, yes, definitely. Probability, sorry, pattern deviation numeric plot. And then By analysis of the raw data, we get what? These four things, which has very crucial role in case of diagnosis of glaucoma. So total dimension numeric plot calculate difference between major retinal sensitivity raw data each point with corresponding point of normal value of same age group and plotted as total deviation numeric plot. We have to compare raw data with the uh, data we have as a normative value. Okay. So the symbol assigned to deviate, and then whenever we assign the symbol p-value, then p-value has a darker symbol for 0.5, a little bit lighter for 1%, less than 1%, a little bit lighter for 2, less than 2%, a little bit lighter for less than 3%, a little bit lighter for less than 5%. And that's how we get basically what we get, the probability finding from the deviation from normal population. And we get what? Total deviation probability plot. Total deviation probability plot, isn't it? The same thing is happening pattern deviation probability plot. So what we do, stat pack eliminates or diminishes the general depression. So basically what we want to do in case of probability pattern deviation, because we want to eliminate general depression of the measurement field, and thus the focal loss becomes clearly visible in ends. So basically pattern deviation numeric plot in which focal uh, visual field defect is enhanced. How will do? Total deviation numeric plot minus seventh best positions to become 0. We want seventh best position of total deviation numeric plot to 0, isn't it? The symbol in the probability plot assigned to each deviation indicate probability finding a such a deviation in normal population. The darker the symbol, greater the probability of abnormality, isn't it? And then what we get? Pattern deviation numeric plot. We put to the probability that pattern deviation probability plot, isn't it? It's simple. So establishing global indices from the total deviation numeric plot. So I have already total deviation numeric plot is the father of global indices too. So mean deviation, we discussed two things. One thing is plus or minus sign. Obviously, there is no plus sign. Yes, there is plus and minus sign, and it's p-value, isn't it? So normally, uh, 0 to 2 is quite good. Pattern standard deviation. So definitely there is a deviation value and its p-value, isn't it? So if pattern standard deviation does not carry any sign in front of it, so normally pattern standard deviation does not carry any sign plus or minus. Mean deviation only carries, but it carries p value. If there is no p value in front of in back of mean deviation and pattern standard deviation, then you don't have to think anything. It's normal. Just leave and move forward. So the two things which is not that important is mean deviation, pattern standard deviation. We have not always go for it, but yes, this is definitely important. It's corrected pattern standard deviation. Basically what it corrects, short-term fluctuation. So basically there are two things: corrected pattern standard deviation, that is short-term fluctuation corrected for pattern standard deviation, which is also decibel value and its p value, and short-term fluctuation has decibel value. Okay. Then other things that is important in establishing glaucoma Hemphill test, isn't it? And glaucoma from pattern deviation numeric plot, it's very important. Pattern deviation numeric plot. So from pattern deviation numeric plot you got glaucoma Hemphill test. What happened in glaucoma Hemphill test? It is an index and developed to pick the dissimilarity among the loss of sensitivity corresponding to the point each other to horizontal axis. From horizontal axis there is a 5 zone and the mirror of the 5 zone in lower below horizontal axis, isn't it? So it's very helpful for glaucoma, early pickup of the glaucoma, early detection of the glaucoma. We can stay in the glaucoma Hemphill test is nothing, we can say it's nothing but refined pattern standard deviation, which is very useful to understand. So there are five things that can happen in this analysis, isn't it? Glaucoma Hemphill test, there is outside normal limit, that's borderline, abnormally low sensitive, abnormally high sensitive, within normal limit. If these four things are not there, then it will be within normal limit. In general, that's this is the summary of stat pack using single field analysis. That's raw data. From raw data we derive total deviation numeric plot, and from total deviation numeric plot there are two things. One thing that derive is pattern deviation numeric plot. Another thing that is derived is global indices, pattern standard deviation, mean deviation, and all those things. And from total deviation numeric plot, we derive probability plot. From pattern deviation numeric plot, we derive probability plot. But from pattern deviation numeric plot, we divide Glaucoma-Hemphill test. It's very important. Pattern standard deviation and this indicates the pickup of irregularity surface. That's why Glaucoma-Hemphill test we also called almost pattern standard deviation. So these two things are very good. Pattern standard deviation and Glaucoma-Hemphill test for early detection of the glaucoma. Okay, early sign of the glaucoma is very important. So in finally, the features of single field analysis and change analysis printout with four major threshold strategies are follows. So basically four major threshold means full threshold, fast pack, CETA standard and CETA fast. These are the four main things. Okay. So what are the difference in reliability indices? So false positive error, false negative error, fluctuation loss are indicated in fraction like for this section. And in case of fastback, false positive error, false negative error, and fixation loss are indicated in the fractions, same. But in case of this, false positive error, false negative indicated in percentage. Okay. In case of CETA fast, it's indicated in percent. In case of full threshold and start back, it's indicated in fraction. Short-term fluctuation is not a function of CETA. Okay, just remember, short-term fluctuation is a function of definitely fast back and full threshold, not a function of theta. That's definitely, if there is no short-term fluctuation, there is definitely not corrected pattern standard deviation, because corrected pattern standard deviation is correction of pattern standard deviation for short-term fluctuation, isn't it? So that's why it's a function of full threshold, it's a function of start back, it is not function of theta, whatever standard or fast. Glaucoma infiltrate, yes, definitely, it's always there in all cases. Okay, change analysis printout. So basically, full threshold it gives like normal box plot print on the left side of the decibel scale, and in case of fast pack strategy, normal box plot print on the left side of the decibel scale. In case of CETA, normal box plot not printed on the left side of the decibel scale, and normal blocks not printed on the uh, left side of the basic scale. In case of CETA, there is no plotting of in left side of the what do you call it, decibel scales. Okay, but they are do in full threshold and fast pack. And time test, you always understand time used for determining the threshold of all points is always compared with full threshold. Okay, the most standard way to determine the threshold sensitivity, because full threshold is Starcast method, that's 4 dash 2 dash 1 method, Starcast method. Okay, fast pack is 40% of the full threshold, it means 60% less, isn't it? 40% of the full threshold. CETA standard is 50% of the full threshold. Okay, so CETA standard is 50% of the full threshold. But remember, see, CETA fast is 50% faster, 50% of fast pack strategy. 50% of fast pack strategy means 20% of full threshold, isn't it? It's only 40% of full threshold. It's half of the CETA is fast is a half of the fast pack. Then it's what do you call it? Indirectly 20% of the full threshold. So that's why CETA fast is so fast. Okay, so fast. So at last, in summary, I want to tell you that it's very important. Don't ever read visual field isolated. Its usefulness is like question marked. So it's always a clinical correlation is paramount important, and one should never interpret visual field in isolation. Never. Just remember this. Okay, clinical findings is so important. So that's why you should never interpret visual field in isolation. That's it will be very difficult. You have to have your OPD card. You have to have see your optic nerve head with the glaucoma specialist, and then interpretation is this. But as an optometry student, you must know each and every point. Okay. So again, I have already told you I'm a big fan of G.R. Reddy's book, and just buy this book, see these prints by in your hand. It will be very great. Okay, so this is also another great book. Okay, I think that's it. Um, I'll make one video more. So be done. Choose.